Hello, folks, and welcome to my presentation. This is Matt Morash. My research has been a pencil to paper lesson versus a digital treatment, which I think is incredibly relevant for our current global climate, where we might all be asked to teach online in the very near future. So my research question was, how does the use of Let's Talk Science's Living Space Action Research Project compare to a traditional paper and pencil teaching methods when measuring student engagement and acquisition of learning outcomes in a grade 9 mathematics classroom? Now, before I get into those two treatments, let me talk to you a little bit about my context. I teach grade 9 math. 31 of my 49 students consented to participate. I'm at Forsyth's Community School, which is in rural Nova Scotia on the South Shore. We have a couple of different technology hubs throughout our school with Chromebooks and iPads. Most students carry personal devices, if not one or more. But access to technology at home still varies quite a bit. Some of our students have a commute of upwards of an hour, and they're still relying on dial-up internet, and their experience at home doesn't use a whole lot of technology. The first treatment we'll look at is one that is presented by Let's Talk Science. It's the Living Space Action Project. It's a collaboration between the Canadian Space Agency and astronaut David St. Jacques. The lesson design has students consuming digital materials on the environmental conditions that impact their health, both physical and mental. Students do some coding using the CanCode program via a microbit, which is a mini remote controller, and they get that to communicate with a COSR sensor, which is the same type of sensor that is used by astronauts on the International Space Station. The data that's collected over 3 days is then graphically represented. Students look for patterns and implement solutions to try to improve their living environment or their working environment in the classroom. The three different factors we chose to look at are the relative humidity as a percentage, the temperature, and also the carbon dioxide parts per million. Learning is fluid, it's in pairs or groups, there's Chromebooks out, students are moving back and forth between the sensors and the microbit, and it seems to be like a very engaging project. The second treatment was a solving equations lesson. That's my pencil to paper lesson. It's a 3-part class. It has teacher instruction, affirmed consolidation, and then independent practice. This looks like students recording from a smartboard, some scaffolded step-by-step. Then they do some questions where, as a group, we make sure we're all on the same track. And then students do some independent practice with an answer key to the side. And I will rotate around the classroom answering any other questions that they may have. So what does the literature say about this? It says that students are actually less motivational and adaptive towards math in early high school, meaning that their ability to adapt in math is reduced the older that they get. We also see that math educators can impact their students' learning by integrating something that they're interested in, which I think is what this project was, the Living Space project was aiming to do. This type of learning will become rewarding because students need to negotiate solutions to an authentic problem in the real world. And technology-based learning can have a mixed, varied set of results. It can cause students to improve, or it can actually set them back and harm them, or it can have an unchanged effect, as with other treatments. Students who are often struggling in school, though, are left behind by comparison to their peers who have regular access to technology at home and at school and in their communities at large. So what my research is aiming to do is there's very little available on tying the three ideas of technology-enriched learning, student engagement, and academic success all together. There's lots tying 2 of those ideas together, but not all 3 at once. My measurement tools I used was I decided to do a pretest with students just before the lesson started to see how well they understood their outcome, do a post-test the next available math class, and at the end of the lesson, do an effective engagement survey to see how they felt about the quality of their engagement. The post-test will tell us how well the students retained the outcome from the treatment and how well they've consolidated that outcome into what they already know. My pre-tests look like just what we have here below. They're level 1 knowledge questions, and the same outcome is covered in both. I have an affective engagement survey, which was done at the end of the lesson using a Likert scale of even numbers to avoid patterning. And I used the methodology of RATE, which is a rapid assessment of information technologies, and this allowed more and more key stakeholders to come on board with this project so that they could tell me a little bit or give a little bit more advice and feedback as this project progressed. Let's take a look at the results, shall we? If we take a look at the effective measurement survey, I noticed a number of different things. Students in general seem to enjoy the pencil to paper lesson more than the digital lesson. They felt like the pencil to paper lesson held their attention from the start and until the end, whereas by the end of the digital lesson, they had actually lost their attention. Their mind then was more likely to wander during the class. I also noticed that there were a few invalid data points. These invalid data points probably happened because of the even number of answers that they could have. So some students didn't identify the lesson as being boring or not boring. And also there were a few data points that students wish we could have more lessons like this in the future. They felt, I don't know if I feel either way about that. Now, what is interesting about these results too is that in both lessons, students felt that they were trying to figure out how the outcome fit in with what they already know. However, with the digital lesson, they did a better job at applying how it might be relevant in the real world, whereas with the solving equations, they couldn't really figure out how that was relevant to the real world. Let's take a look at the pre- and post-test results. I noticed a couple of very interesting things. If you look at graph 1, pencil to paper lesson, I noticed this like shouldering effect where the maximum is the same as the Q3 mark. That's shown by the capital letter A. That means that students came in with a very good understanding of this outcome. Some of them had already mastered it before the treatment. We notice that the mean and median both have a pretty significant increase here, and that the lesson has shown to work because the range of values has shortened. In graph 2, the digital lesson, I noticed that there was quite a shortening of the range and that the mean and median also improved. However, when we take a look, and this was very something fine that led me to ask some more question. In B, what I've got there with a capital B, I show that the Q3 value has actually decreased. And I thought that this might have suggested that a quarter of the students were actually harmed by this lesson, meaning that their outcome understanding was worse after the lesson than it was before. So that forced me to dig a little bit deeper. Let's take a look at the individual changes in scores. I took the values and I looked at their post-test and pre-test results, subtracted them to see whose scores went up, down, or were unchanged. And I noticed that 7 students with a digital treatment were actually harmed and were worse off for the outcome after the lesson, compared to only 3 of them with the pencil to paper treatment. Putting this all together, I saw 3 things. 1, students were identified they were less focused and didn't enjoy the digital lesson as much as the pencil to paper one. 2, the mean and median increased for both lessons, however the pencil to paper did a little bit better. And 3, more than twice as many students were harmed by the digital treatment than the pencil to paper one. In my discussion, my conclusion really led me to more questions. Should all digital interventions be halted? And I think, in short, the answer is no, and I'm going to get into this in my personal reflection. Should educators favor traditional learning styles? I think there's certainly a place for tried and true methodologies. There's a reason that those have continued. 3, what needs to be considered if implementing new teaching strategies? That's a really great question, and we need to look at the group of students that is actually in front of us on that day. What sort of history and baggage they come into the classroom with, and what sort of access they've had in the past. The implications of this research is that the digital divide really persists. And I recall during my lesson, I had some students that were, asking me questions that I had no idea that they would get lost on. For example, like switching between applications, or how to access a file, or to download something. These were things I had not anticipated that they would not understand. Student motivation is also then linked to that, and this is then linked to their prior mode of learning style and how they were taught. So in order to narrow that gap, I think that technology should be integrated earlier and at home for the divide to be reduced. My suggestions for future research are, 1, that obviously we continue to contribute to this growing body of research, tying these 3 ideas together of how students are engaged with their learning, their outcome consolidation, and also technology engagement tools. 2, we need to find a way to control prior learning styles to divide into subpopulations. For example, looking at Students who enjoy learning digitally and have learned digitally in the past, how do those compare to students who have neither done either of those things? And 3, we need to sample larger groups and have different content areas of students with more diverse populations instead of just my rural setting. Now, I really noticed that some students got excited about this. It led to some students who I was not teaching at the time participating in the Tomato Sphere project. And then there was this grow setup in my classroom where some students wanted to grow lettuce and some herbs and beans. There were then some partnerships, and then some funding came in. And in the end, 2 of my students applied for SHAD Canada, which is an exclusive science camp that lasts 30 days in the summer. So although this research says that this one treatment in this one context in this one scenario for this one outcome harmed nearly a quarter of my students, it doesn't really measure how much it benefited those that it did. So I was reminded of a quote that Mr. Jim Dexter said at one of our presentations from Warlock 2016, and that was, "We need technology in every classroom and in every student and teacher's hand, because it is the pen and paper of our time, and it is the lens through which we experience much of the world." And I found that truly relevant in this context. Well, folks, I am really looking forward to some of your feedback and learning a little bit more about your research. I hope you enjoyed my presentation today, and congratulations on making it this far in the program. Thank you. Bye-bye.